Hello everyone, I welcome all of you for this IGBC AP Exam Preparation course. Myself Saravanan J. Bharati from Carbon Figure Academy. In this module, we will be talking about sustainable building materials and resources. So, if you take a building, there are a lot of various categories of materials will be poured into its construction. So, if you take the basic construction materials, it would be like cementitious materials. So whatever is being used for bonding and adhesive purposes, especially for components, major components, except paint and those kind of adhesives. Then metals, then masonry products like bricks and blocks of all kinds, then glass and wood based materials, right? So if you take the manufacturing scenario of each of these material, it would be like this particular given formula. So it is taking energy as input, it might be electricity or fuel or gas, plus certain natural resources. So that ultimately gives you the manufactured construction materials. So if you see the global level perspective about the construction materials and their manufacturing. So for example, limestone and iron ore has been provided here. So it is like annual production for the recorded year 23 and 24. Limestone was like 407. So the annual production of limestone was in the year 23-24, it was about 407 million metric tons. So the remaining estimated reserves in million metric tons is 20,000. So years remaining, in this same level of procurement, if you take or unearth the limestone from the available deposits, so it would be like we have some another 50 years so to take up limestone. So after that 50 years, we don't have that idea, right? Until any further new deposits of limestone would be identified. So what are the purpose for which limestone is being used? For the production of cement and construction materials. So global rank, if you see, limestone holds third in the production. So third most used mineral for the construction manufacturing, construction product manufacturing. Next one, if you take iron, annual production, it goes around 275 metric million tons or million metric tons, right? So reserve only 9,000. So years remaining, obviously some 32 to 33 years is being estimated, right? So what's the ultimate use of iron ore? Steel production and infrastructure development. Global rank, if you take, it holds fourth largest utility in case of construction product manufacturing. So on other words, from a wood based material perspective, global deforestation rate is being mentioned as 13 million hectares every year across the globe, right? Which means that much amount of forest is getting vanished or disappeared or completely consumed for the purpose of wood-based construction material production and manufacturing, right? So in this kind of existing context and scenario, so how we can term a material as a sustainable one, right? So sustainable material usage in buildings encourages reduced dependence on virgin materials that have associated huge amount of environmental impacts. So there are a lot of criterias given for defining a building material as sustainable, but still as a building perspective, not with respect to a particular material or component perspective, IGBC deals as a whole building. So from that whole building perspective, there are certain criterias or certain focused areas they have listed, under which when we try to implement certain degrees of activities that can contribute to the building as a sustainably built built building or built environment, right? So it is like again, their usage in buildings encourages reduced dependence on the virgin materials that have huge amount of associated environmental impacts. So what are the focused groups? As per IGBC framework, building reuse, that is the very first thing. Then reuse of salvaged materials. Then materials with recycled content. Then local or regionally sourced material. Then finally wood-based material. So which means that wood must be responsibly produced wood, right? What is mean by that, we will see that, right? So it is like in the order of activity. So first you should try not to demolish a building, right? In the purpose of with the purpose of building a new one, right? You try to reuse the existing one. That is the first scenario. Okay, if it is a plain land and if you are going to construct a new building, means try to use the salvaged materials, taken out from the old buildings. That is the second order. Third order, if you are going to use the new material, means try to get the materials with reasonable recycled content, not completely some virgin material, right? That is the first thing. Second thing, with respect to the new material, you try to get it from the local. Don't go far beyond to get those materials, because those are all would be linked with more amount of transportational impact, right? Then the last degree of suggestion is try to go for wood based material, right? Especially from responsibly grown forest areas, right? Which means renewable wood, right? So whatever can be cultivated within the span of 10 years can be mentioned as renewable wood material. So the first thing is building reuse. So try to reuse structural and non-structural elements of the existing building. Ensure that they are retained, right? Then perform a detailed building survey to identify the extent of reuse, because not the entire building might be useful for your intended purpose. So take a clean survey and try to come up with some identification, so that these zones can be converted successfully with respect to our intended new building purpose. So these zones cannot be used, so they can be used as a storeware or storeroom or some server rooms in case of IT companies or all those things. So that's the thing. Then structural elements, columns, beams, floor slabs, exterior walls, structural glazing, etc. This is what they meant as structural elements. In case of non-structural elements, they include interior walls, ceiling, flooring materials, doors and windows, etc. Right? So in the given picture, so they have given that typical example of reusing the existing building as a new one, right? So from left to right, you can able to see the changeover from the existing scenario to the newer one. It just gets looks like gets upgraded, right? So that is nothing but Ambuja Cement Corporate Office, which is located in Gurgaon, right? Then reuse of salvaged materials, right? So materials that were used in the buildings are salvaged or reused or refurbished material. That is the definition or meaning of salvaged materials. So which means that existing building might be demolished, might be out of use. So whatever the possible extraction can be done, people do it, and they just send it to the local market for some resale. So from those kind of reselling point, you try to get the certain materials for the purpose of your own new building or interior development of your existing building for whatever the purpose, right? For simple example, the frames, the doors from the previous old building can be successfully reused in your proposed new building, right? So that would be the simple example. Then verification of durability and performance is very much important, because not all the materials from the old building can be straight away used for some important purpose in your new building, like the load bearing aspect, right? So especially when you would like to take away columns, beams which are made with wooden components, should be checked for its durability and adequate performance, right? So that is very much important. Apart from load bearing purposes, any other purpose or aesthetical aspects, there is no worry to thing. Then in case of wood, then you just retreat the surface so as to preserve them against termite attacks. So those kind of preliminary things. And then if it is a steel structure or any metal based things, then we don't need to worry at all, because it would be staying there, right? So as long as you just keep their surface rust free, right? So common salvaged materials, what they are telling, it would be furniture, it could be doors, cabinetry, bricks and tiles. When the demolition happens, the old bricks can be taken out, and especially when the existing building has lot of impregnated tiles on the walls, then those can be successfully taken out without much damage. So those tiles also sometimes can be reused. And flooring tiles especially, if you carefully do it, you can extract almost 90 to 95 percentage of existing floor tile as it is, without getting serious damage. So those tiles can be successfully reincorporated in your new building as it is, like a designer appearance or as actual floor appearance. So anything it might be, right? Then materials with recycled content. So what they are suggesting, use materials with recycled content, reduces dependence on virgin materials. Obviously recycled content decreases the virgin ratio, right? Then types of recycled content is there. So when you mention recycled content, means it might indicate two different things, which is post consumer recycled content or post industrial recycled content. So if you are claiming your building product holds recycled content, means you should be able to specify whether it is post consumer or post industrial. So what is mean by post consumer waste? It is the waste material available after the consumer use, right? Example, a tetra pack, used bulb, plastic covers, all those things. Post industrial waste means the waste material that are generated during the manufacturing at the site itself, which means the plant itself. For example, fly ash, particle board, wooden cut pieces, or those kind of things, especially from the manufacturing yard. So post consumer waste as well as post industrial waste can be successfully reincorporated in the manufacturing of new materials or new products. So you should assess the percentage of either post consumer or post industrial, so as to provide your information on materials with recycled content. So there would be certain formulas, so how to arrive the final percentage of recycled content in your product. So accordingly you have to get the data and just put it in the formula and finally show up the number. Okay, these many different materials all together, my new building is going to use this much amount of recycled content for a given floor area, or like that, right? You can specify in that way. So we can say we can see it here how it is getting calculated. So typical building materials are there with recycled content in the market. So in that sense, fly ash blocks has 30 to 40% recycled content. Then glass 10 to 15. I wonder glass could be more, but still it is mentioned this way. Then ceramic tiles 20 to 30%. MDF, I think it would be some plastic stuff, 30 to 50 percentage. Then steel and cement 25 and 20 to 30 percentage. Steel and all, nowadays people are going with more amount of percentage. up to 95-97 percentage, but still this would be like industry average, we can say, or existing scenario. So how to arrive at the recycled content? So how to do it for a given material and for the entire project, right? So it is like for a material, the recycled content is equal to post consumer plus 50 percentage of the post industrial. So you may think recycled content comes in two different ways, post consumer and post industrial. That is fine. So they are going to add it. But why they are considering only 50 percentage for the post industrial waste? Because it is comparatively easier to recycle post industrial waste into the manufacturing of that particular product, because those waste are going to emerge in the manufacturing plant itself. But post consumer waste, it happening out of the manufacturing plant at the end of the product life cycle stages. So that thing is getting reused means that has more significance, that has more efforts in the background. So to acknowledge that, they are 100 percentage accounting post consumer waste, whereas they are just accounting only 50 percentage of post industrial waste, right? So it is indirectly encouraging using more post consumer waste so as to increase your recycled content percentage, right? So for a given project means how that value comes, it is like percentage post consumer recycled content multiplied with the material cost plus 0.5 percentage pre-consumer recycled content. That is nothing but post-industrial, right? Don't get confused. Same way. So in terms of post-consumer recycled content and their material cost plus 50 percentage of that, pre-consumer recycled content into material cost. So how much percentage it would be? Total recycled content value into 100 percentage divided by total material cost for the given project. So this is what the particular formula I was talking about with the previous slide. So this is how the IGBC accounts the recycled content in your building materials and in your entire building project. So if the total material cost is not clear, consider 40 percentage of the total project cost, because while doing it we might not able to completely arrive at the material cost at the beginning stage, especially when you are going for pre-certification stage or very design stage kind of things. uh, you know, uh, so there you might not be able to arrive at the exact material cost. So you can assume total project cost, out of which 40 percentage will go to uh, the material cost. So from that you can calculate the recycled content and their percentage, right? So at the bottom, that is what being given, why the 50 percentage is only getting accounted in post industry waste. So they are easier to recycle. So it is like giving fair credits. Giving it 50 percentage credit ensures realistic accounting, as it avoids overvaluing materials already recycled within the production process, right? Then encouraging post consumer recycling, prioritizing post consumer waste as 100 percentage as it is indirectly encourages recycling of materials used by consumers, which is harder to collect but has a bigger environmental impact, right? So that's the reason why post industrial waste holds only 50 percentage into the accounting. Then local and regional material preferences, right? So it is telling you try to choose materials that are manufactured locally. So what is the definition for being local within a distance of 400 kilometer to the project site, right? So which is like, if you have a project site at particular location, you keep that as a center, and draw a circle of 400 kilometer, uh, uh, right, as a radius, right? I think it's not diameter, it's radius. So take a circle, and within that circle, whatever the surrounded areas are bounded with, so from there, if you collect your materials or purchase your materials, then you can call them as locally sourced materials, right? So what is the environmental benefit? Using locally sourced material reduces the environmental impact associated with the transportation emission and respective energy uses, right? So there are certain examples like local stones, local stone for cladding and security wall construction, and uh, the facade establishment with the locally available uh, uh, different types of stones and blocks. So there would be some examples, right? Then wood based material, right? So what are the different things? We have composite wood materials. Use engineered or composite wood products for durability and sustainability. Avoid pure wood products with teak wood, rosewood. Instead, try to prefer composites such as MDF plywood. Medium density fiber, I think so, MDF. Then rapidly renewable. Prioritize materials derived from resources that regenerate quickly. Then certified wood. Ensure wood is certified by FSC or PEFC. So that is nothing but, FSC means Forest Stewardship Council, and PEFC means Program for the Endorsement of Forest Certification. So that's what I was mentioning, like uh, responsibly grown up forest. So those areas, the forest is being governed for exclusively extracting construction products, right? So they will be highly taken care, and they are like bounded with a certain region, and it's not some random forest, you know and they have high governance body that the extracted wood, or whatever the amount of wood has been extracted, it will be replanted immediately. So it will be like, instead of cultivating the wood from random areas, you go to a particular hub, and from there you try to get the wood material. So it is internationally valid and available. So the indication is that FSC sealed or a logo will be provided on to those kind of wooden products. So you just try to check whether your purchased wooden products holds this kind of logo, or indications like PEFC certified or FSC certified, right? So in FSC there are different types of certifications are there, like recycled, made from recycled material, 100 percentage from well managed forests, and it's a mix, means from responsible sources. So three different options are there, right? So we can have like, as I already mentioned, renewable wood means which can be harvested in less than 10 years. Example, we can have like bamboo, bagasse, and eucalyptus, right? So uh, so when they say use wood based material, this is what they meant, right? Either it can be composite wood material. Composite means engineered wood. People used to say, what is meant by engineered wood means, during the production of virgin wood based materials, lot of wood based wastes would be generated. So those waste would be gathered and will be mixed and high pressure compacted and coming up with kind of a new board kind of product. So normally that plywood is actually produced because of those kind of processes only, made from some existing wood products. And also composite in the sense, along with wood layer they would be adding some plastic based layers so as to increase certain engineering properties of the composite wood, right? So that is what they are first telling, composite wood material. Then try to go for rapidly renewable options. Then try to go for certified wood. So when they say prefer wood based material, this is what they mean: composite, rapidly renewable, and certified wood, right? So this is a kind of a simple example from India. Uh, all these bamboo underwent CCB pressure treatment, copper, chrome, and boron. I think it would be kind of a structural enhancement technique of bamboos, especially when they are subjected to larger and broader construction. So this is a clubhouse and India's largest bamboo structure, right? And especially made with Indian bamboo, right? So that's a typical example. And there are certain IS codes. I would like to mention it here, where bamboo is being preferred as alternative for the reinforcement bars inside the concrete elements. So normally people used to have steel reinforcement bars. For the steel, nowadays in the market we could able to see fiberglass based reinforcement bar, like completely glass and plastic polymer is coming up as alternative with huge potential for better and better structural properties than the steel one. But still, apart from that plastic and fiberglass option, there is an option of going with bamboo as also as reinforcement bar inside the concrete. And India has its own IS code with the complete case study, examples, calculations, guidelines, everything, right? But still, in practice, it is very rare because certain skilled executives are not so available. Because when you take reinforcement steel and fiberglass based reinforcement, both would look like same way. There is no much difference in terms of size and length, everything. But if you would like to replace the steel with the bamboo, it's completely looking different, and sizes also, right? So the handling of those bamboos is being, you know it's not so comfortably preferred. That is the reason it is being rare. But it is possible, we have certain IS codes also, right? So that's it. So that's the module 9. And again I am mentioning that each module, for each module you can able to find the respective quiz, practice quiz, in the description box, so that after watching the respective module, if you would like to check up your understanding level, you can go and take that self assessment quiz, which will help you to recollect the entire understanding from the given module. Thank you. We will see in the next video.